Third question of the study guide. The student store sells pencils at 5 for $1.25. Complete the rate table. So 5 pencils cost $1.25. We can easily find out how much one pencil costs. So if 5 pencils cost $1.25, if we divide that value by 125 by 5, we're just going to get 25 cents. Looks a little bit off. And then if one pencil costs 25 cents, 2 pencils should cost 50 cents, and so on. And that should be $2.50. That should be $1.25 plus $2.50, so that should be $3.75. And that's just going to be double how much 10 pencils cost. And that should be 100 times more than what one pencil costs, so $25. So the question, how many pencils could you buy for $20? We see right here, because we fill in our table. It's just going to be $5. Now describe what the graph of this data will look like and name a point on the graph. Well, a point on the graph is shown by a coordinate pair. A coordinate pair would have a number from up here and a number from down here. Now we already have it in a rate table format, so we can choose any number up here, and we have to choose the number that's right below it. So let's say we chose the number 15 for our first number. Our second number would have to be the number right below it that relates to it. So the coordinate pair would be 15 and 3.75. That would be a point in the graph. Now there are all these other points on the graph too that we could have said. We could have said 100, 25. 100 would have went here, and 25 would have went here. You could have said 1 and 25 cents. 1 would have went here, 25 cents would have went here. And to say, describe what the graph of this data would look like, well, what would the line look like if we were to graph this data? Well, we see that for every pencil that we add on, we get a bigger amount of cost. So the graph would look like a line that's increasing or is slanted upwards. But because we haven't really dealt with graphs yet, I wouldn't worry too much about this problem, because we're going to get into that later for the next unit. Now we say write an equation that relates the number of pencils n and the cost c. We want to make an equation. An equation always has an equal sign and variables. So let's say the cost is equal to n, the number of pencils, times a certain amount. Well, if we put 1 here, in order to get from 1 to 25 cents, we have to multiply 25 cents to the 1. If we had 2 here, it would be 2 times 25 cents gives you 50 cents. If we had a 10 here, it would be 10 times 25 cents gives you 250. So the number that would go here is our 25 cents, or 0.25. So this would be our equation, because our number of pencils is multiplied to the cost of one pencil, and that gives us our total cost. Now, what is the constant proportionality? How do you know? Well, when we set up an equation, our constant proportionality is this number. It's this number we're multiplying to our variable. So the constant proportionality is just 25 cents. Well, how do you know? Well, if we look at the graph, it's constantly increasing by 25 cents. For every 1 pencil we add on, we added on 25 cents. So that's something you could have written. It's constantly increasing by this amount every time, 25 cents. Now you might say from here to here, it doesn't increase by 25 cents, but the pencils don't increase by 1 from 5 to 10, they increase by 5. So we kind of just want to focus on these values that increase by 1. And just to point out, unless we're still a little bit confused about how to create an equation, why do we have this number in particular here? Well, we can always look at our unit rate, because really what this is saying is 25 cents per 1 pencil. So for 1 pencil, n, that's going to be 25 cents. and that's where we find our value. And 1 times 25 cents gives us our cost.